Hello everyone, today I'm gonna talk about the lab for glucose non-fermenting gram-negative bacteria. The learning objectives. First, explain the procedures for laboratory identification of non-fermenting gram-negative bacteria. Second, interpret the results obtained from the test for identification of non-fermenting gram-negative bacteria. For the identification of glucose non-fermenting gram-negative bacteria, today we're going to do first gram staining, second oxidase test, and third culture in a McConkey agar at 44 degrees Celsius. We will use the small size plate. For the biochemical test, we will apply the bacteria in a typical sugar iron agar multi-indolysine medium or MIL, Simmons citrate medium, urea agar slant, nitrate reduction test, OF glucose medium, and OF maltose medium, and the last one PR 10% lactose medium. How to apply it? You can see in this picture. For example, TSI, we use the needle to streak at the slant first, and then use the same needle and step to the bottom of the tube. For the MIL, use needle also and step it. For the citrate and urea, need to streak it on the agar slant. For the nitrate, use the lube to apply the bacteria at the upper part of the nitrate. For the OF glucose, OF maltose, and PR 10% lactose, you need to step it for a few times, like 2 or 3 times, to the butt of the test tube. For the McConkey agar, you can streak it for 4 planes and then incubate it at 44 degrees Celsius. The McConkey agar plate is a selective and differential media. For the lactose fermenter, it gives the color as pink colonies. For the non-lactose fermenter, it gives as a colorless colonies on the McConkey agar plates. The bacteria that is the lactose fermenter, for example, such as the E. coli, Klebsiella, Enterobacter, and Serratia. And for today, we taste about the non-lactose fermenters, so it has to give us like the colorless colonies. For such examples, such as Stenotrophomonas, Acinetobacter, and Pseudomonas. So this is the ingredients inside the McConkey agar. The first, solidifying agar for the solidifying agent as a base agent. Sodium chloride is an osmotic balancer. Peptone for nitrogen source or carbon source. Bind salts for inhibit the growth of the gram-positive bacteria by disrupt the membrane. And crystal violets also inhibits the growth of the gram-positive bacteria. Neutral rate is a pH indicator. It turns red or pink when pH drops below 6.8, so it's the acid range. For the lactose, it is the carbon source that some bacteria consume the lactose and produce the acid that change the neutral rate, the pH indicator, to below 6.8 and gives the pink colors. For the triple sugar ion or TSI agar, it has 3 sugar added in this taste, which are 1% lactose, 1% sucrose, and 0.1% glucose, and the iron in the forms of sodium thiosulfate and ferrous sulfate. The indicator that used in here is phenol rate. The principle of this test is used to determine the ability to reduce sulfur into hydrogen sulfide that gives us the black color. And the determine lactose, sucrose, and glucose fermentation, and also gas productions. So we have 1, 2, 3, 4, 5 symbols for this taste. The K stands for alkaline. The alkaline gives the color red. The A stands for acid. So if we have the acid, this indicator of the phenol red will turn yellow. So at first, we're gonna start reading at the slant, followed by the but. So we have here alkaline with the red color at the slant. So we put the K on the slant and slash with the color of the but. So it's the acid that gives a color as yellow. So in this case, we can determine it and result it as K/A. For the sample number 2, we have the slant as yellow, so we interpret it as acid, and the but is an acid as well. So we can read these as A/A. For this tube, we have the black color, all the black color in this. So we give this as the acid/acid with the plus. This plus stands for hydrogen sulfide. For this, we have the K with the alkaline, stand for alkaline, which give us the red color, and the but that has the hydrogen sulfide and the acid. So we read it as K/A plus for these two. And after the last one, we have the acid slant and the acid but. And also we got the gas here as well. So we can read it as A/Ag. And the last one, if the agar or doesn't change any color, so we give it as N, which is neutral. So this one, at the slant, we got the red color, and the bottom of the taste, we give a neutral color, which doesn't change any color at all. So we give this as a Kn. For the motility indole lysine or MIL medium, what we can read in this test is motility LDA, LDC, which is stand for lysine deaminase and lysine decarboxylase, which is at the slant and at the butt. And also what we can read more is indole. So the first, we observe the motility first. So we see the turbidity of the agar media. If it's turbid, that means these bacteria can motile. So we got it as a positive result. For the LDA or lysine deaminase, we look at the slant or the upper part of the medium. So if the positive, it gives red color. If it's negative, it gives a purple color. For the lysine decarboxylase or LDC, we see the bottom of the agar medium. If it gives a positive result, the purple color will appear. If it's yellow, it means a negative result. So after You read about the motility, LDA and LDC already. The last thing is you need a coax reagent applied for 8 drops and read the indole and read the results. If it's red, it means that indole is positive. But if it's yellow, it means that indole is negative. For citrate and urea, citrate, if you see it as a green color, you give it as a negative. And if it's blue or turquoise color, as here, you give it as a positive. But if you have some part of the agar slant that gives the color as blue or turquoise, you can give it as a weak positive. For the urea, if it's negative, it gives you the yellow color, and for the pink color, it is a positive. For the reaction of the indole taste, start with the substrate of tryptophan. If the bacteria can produce the tryptophanase, it will give the product as an indole and pyruvic acid. So when you add a coax reagent in there, it will give you the red color. For the citrate taste, the substrate is a citrate, and if the bacteria has a citrate or citrate permease, the product is an oxaloacetic acid, and it becomes as a pyruvate, carbon dioxide, and excess sodium, which gives the alkaline pH. So the agar will turn blue or turquoise as a positive result. For interpretation of oxidative fermentative taste or OF taste, in this experiment we use one-tube method. So in this OF taste includes sodium chloride, dipotassium phosphate, peptone, bromothymol blue, agar, carbohydrate, sugar for 1%, and water. So how to interpret the results? So look at these two test tubes. There is no change in color. So these can be read as non-saccharolytic or non-oxidizer. It means that bacteria don't use any carbohydrates, sugar as an oxidize or ferment. In these 3 test tubes, there is a yellow color in the top of the agar. So this means it needs to have the oxygen to consume the carbohydrate or sugar. So this means oxidizer. And if you see the yellow in the butt of the agar, it means that this bacteria can use carbohydrate in the fermentation method. So we interpret it as the fermenter. Laboratory identification. Pseudomonas aeruginosa. The key of the biochemical taste is the oxidase that gives a positive result, TSIKN, can motil, as in the sim. Citrate and urea and the nitrate gives a positive result, and nitrate can has a gas. OF glucose gives it as an oxidizer, which has the yellow color at the top of the taste tube. For the OF maltose, give it as a non-oxidizer. Gelatin gives a positive result. For DNS, biasculin 10% lactose and the arabinose give the negative result, and OF lactose give the non-oxidizers. for Acinetobacter baumannii, in the gram staining, you can see the dipolcocci or maybe the gram-negative coccobacilli in there. The key biochemical test is the oxidase test is negative. TSI still Kn can multile citrate, urea, and nitrate gives the positive at citrate, and urea and nitrate gives the negative results. For the OF glucose gives the oxidizer. For the OF maltose gives the non-oxidizer. For 10% lactose and arabinose give the positive results. For the biescaline, gelatin, and DNS give the negative results, and OF lactose gives the oxidizer. And also this Acinetobacter baumannii can grow in 44 degrees Celsius. Burkholderia sebacea is a gram-negative bacilli or gram-negative rod. In the blood agar got as a smooth race, non-pigmented, and gamma hemolysis. You can get the earthy odor. It smells kind of earthy, like a soil smell. So in the McConkie gives a non-lactose fermenter, and it can grow at 37 to 42 degrees Celsius. And it can give the bright yellow pigment on the TSI. As in TSI, we have the iron as an ingredient. And here is the key for the biochemical test. It gives oxidase positive, TSI still Kn, can motile, citrate, urea, and biescaline gives the positive results, 10% lactose positive, and negative at nitrate. For the OF glucose gives the oxidizer, and OF maltose gives the result as oxidizer as well, and also OF lactose. So Burkholderia pseudomallii. In this blood agar, you can see it as a small, smooth colonies in the first or 2 days. So after that, when you extend the period of time, the appearance will change into the extended dry and wrinkle colonies, similar as a pea stuteri. And in the McConkie agar gives a non-lactose fermenter, a non-lactose fermenter. For the gram stain morphology, it gives gram-negative bacilli with the bipolar staining, which looks similar as the safety pin. And the OF test, the OF glucose gives the positive result, the same as the oxidase that give positive results. It can grow at 42 degrees Celsius. And for this, arginine dihydrolase gives a positive result. For LDC in the MIL test gives a negative result. OD gives a negative as well. For the gelatin hydrolysis, it gives a variable. For nitrate and motility gives a positive results. Stenotrophomonas multifida. It gives the key biochemical test as the oxidase gives us the negative results. TSI Kn can motile, citrate positive, urea biescaline and nitrate negative. For OF glucose is the oxidizer, OF maltose oxidizer as well. But in OF lactose is a non-oxidizer. So just only the maltose can give the oxidizer results. So this is the table that you can compare between among the bacteria for today's laboratory experiments. So for today's experiment, again, you be given unknown on a McConaughey agar, one plate for one person. What are you gonna do with this unknown? First, gram staining. Second, oxidase test. The third, culture on McConaughey agar with a small plate one and incubate it at 44 degrees Celsius. For biochemical taste, you have 8 test tubes. So it is TSI, MIL, citrate, urea, nitrate, OF 1% glucose, OF 1% maltose, and PR 10% lactose. And for day 2, read the result and identification and discussion with your advisor. Thank you.